Okay, so today's lesson is basically about some integral properties, which I would consider to be pretty much common sense, and probably you will too. But just to kind of look at them in this light, look at it from, and understand that it actually is something you can do. But most of this should really just make sense to you. All right, I'm going to look at these examples that I have here and using this graph. So the first one says, if negative 2 to 2 equals 10, and from 2 to 5 equals negative 8, can you determine negative 2 to 5? So if negative 2, I want to make sure I'm doing this right, negative 2 to 2 is 10. And then from negative 2, is that 2 or is that 1? I got to make sure I'm not doing that wrong. Okay. We got negative 2. Sorry, it comes all the way here to 2. It's just hard to read those numbers. I'm sure it is for you as well. If this whole section is worth 10, and then from 2 to 5, this whole section, we're saying is negative 8, what then would be from negative 2 all the way to the end? How would you do that? I hope it's obvious. You'd get 2. How about the next one? If I said to you that negative 2 to 0, so from here to here, this section is 5, and I said from 2 to 5 is negative 8, what do we know? How could I figure out this section? How could I figure out what the whole thing is from negative 2 to 8? And of course, there is symmetry here, so we can assume that's 5, and so again, we get the answer of 2. All right, how about if I said negative 2 to 0 is 1. So from here to here is 1. And then I said from negative 2 to 5, just use a different color, negative 2 to 5, so this section here, along with all of this, all of that is negative 1. How would I figure out what 2 to 5 is? How could I figure out this section here? So if I know that 1 and is this little section, and then the whole thing from negative 2 to 5 is negative 1, what we want to basically recognize is that whatever this is, and if I called that x, when I add that to 1, it should equal negative 1. Does that make sense to you? Of course, it doesn't in this picture, but I want you to follow what this is basically saying. If we know from negative 2 to 0 is 1, and from negative 2 to 5, this whole picture represents negative 1, then what we're saying is 1 plus that area has got to equal negative 1. And so the simple thing is just to find it as negative 2. And there it is. All right, let's look at another one. All right, how about this way? What if I said from 1 to 5, okay, 1 to 5 is 5. Again, by the picture, it doesn't appear to be, but let's just pretend. So from 1 to 5 is 5, and from 5 to 7, so from 5 to 7, whatever that is, maybe it's up here, we don't really know. But let's just say from that section, that is negative 6. Or sorry, 3. Find from 1 to 7. So in the same way, what are we going to do? If we know from 1 to 5 and then 5 to 7, and I want 1 to 7, then the deal is we can just add those together, right? Makes sense? If I said from 1 to 5 is 5 and 5 to 7 is negative 6, then from 1 to 7, all we'd have to do is combine the two together to get negative 1. The ones that make it a little bit trickier is when you're looking at these next ones where they give you the whole piece. So they're saying negative 2 to 8 is negative 3. So from negative 2, I'm just going to write it like this. So that whole thing is negative 3. That's what my total is going to be. But from negative 2 to 0, this section here is worth 2. So then 0 to 8, how much does that have to be? Similar to the question we did before, 2 plus something has to equal negative 3, because those combined should equal from negative 2 to 8. And so, again, to solve, you get x equals negative 5. The main property that this is basically illustrating is that I can go for integral a to b, okay, f of x dx, plus integral from b to c of f of x dx. And that would equal from a to c f of x dx. And that is the number one property that we're looking at in these illustrations.